Okay, my friends, hello everyone, and welcome to this new episode of EagleFly, the experimental debugger. It's been a pleasant day and pleasurable. And I think today we're gonna continue coding EagleFly as much expected. And yeah, so please, if you have any questions about the project, any inquiries you might ask, feel free to ask them because I'll be there to answer all your questions. You can post them on Twitch, Twitter, or YouTube. And yeah, for now, I think we're going to start coding. So let me see where we left off. Basically, we were implementing this kind of where is it? Inside here, yeah, the get lexical scope. And I mean, we pretty much didn't do too much about it. It was just like, hey, we have like this idea of how to get it. I mean, we pretty much the whole work is gonna be done by the parser itself, so that we don't have to do pretty much anything. Although it will of course it would be nice to have some kind of mm, I don't know, well, more kind of a usage case. I mean, because if you think about it, well, this is like this lexical scope. I mean, thing that happens here. The thing that we can do now, of course, is to I don't know, like kind of dump this out, And I've defined this, but we don't use it right now. It's just like the kind of thing. I mean, we will like kind of yeah. I think I mentioned this before. We are like kind of bouncing around through the code base, so we can like like this kind of puzzly thing that you put a little piece in one place and then you put another piece in one place, and that's how code goes. That's really important to mention because coding is a puzzle, so you have to be like working around, filling out the gaps and spaces, all the squares that where you can fit them into, and you go from that place. You start there and you go to the place to the node. That's how code works in a nutshell. And sorry, please don't bother me right now because it's an important day. So yeah, with that explained, I would like to go and put the other piece of the puzzle here. And this piece of the puzzle might be that we need to finish this up. Probably we can pass this into the PDB so we can define this usage case and extract it. So because if you think about it, well, we've been like working like blindly without data. Uh, each data it's inside the PDB, but the PDB is not totally done yet. So we have to go and do it. So the last thing we did was that we left tab on the place where we had a way to get the substreams out of the PDB file streams, which is basically each substream defines some kind of different data that resides inside the PDB. It can be other streams or it can be specific image specific data that's going to be that can be like build specific or image that resides in the image file itself. But now the thing that we care about it's about this substream called the mod substream or the module substream, which basically has all the modules loaded by the PDB. Well, not the PDB, but the linker itself, which are object files and libraries. And so we have the DBI stream, and the DBI stream basically is the one that holds all the substreams in this case. and we create this substream, that's the module substream, which has all the streams, all the module streams that we can get out of it, you know. So let's see if we can get all of them, or at least, well, we don't care too much about all of them, but probably I think the most important one for now could be our own module, you know, this module, the object file that we compile with when we do the tracer. No, where is it? The test, the look target, yeah. So we compile this test, and we have an object file translation unit, which basically it's dumped into the PDB file itself. So we are looking forward to get that module information for this object file. And yeah, so let's try to do that. I would like to go and define, you know, okay, so now I see here, like, we created and we are like, hey, get me all the modules from PDB, and get all the modules. Well, it doesn't do anything, but doesn't matter, we can do all that stuff itself. So the first thing I would like to do is go back to the information that we can, so we can say, well, what's the layout of it? It was inside here. Okay, this is, here you go, this is the module information stream. And if I do believe I create, oh, this is one. Probably we don't want to do it right here. Well, probably it's here, I guess. I'm gonna get all the module streams and the module itself, we don't pass it, but doesn't matter because I can pass it. P manager first module. Okay, I see how we were like thinking on this thing. Like, hey, we got all the modules, and I wanna go directly to that place, yeah. Which I don't remember basically how did that work because it's been a while since we did this. So it was not here, it was not here, it was here, and there you go. This is the module info substream, and we, okay, so yeah, we're gonna have an array of these ones, which we didn't, I don't know if we get it or not. Yeah, what does create substream does? PDB stream memory index size, EPDB substream result, P manager substream pointer is just gonna, well, it's gonna just create the substream and make the pointer go up. Alright, okay, so we place the base every time. Okay, that makes total sense. Let me see what we have here. We have the manager, we have the substream pointer, it's moving around, it's good. And alright, so we probably got that information in the EPDB substream, which basically has, let me see, where's the struct type of here. It's around struct for getting out the data. We don't have any kind of information inside there because I believe it was like pretty much a special case for each kind of substream, so that's why we got it like it was a generic thing that we had here just for size, the base, and the string that it was residing into. Okay, so that pretty much makes sense here. So I can go to the tracer and I can get, so like, hey, I want all the substreams so basically get all modules. It's gonna do something special. I see. Oh my god, it's gonna try to get the whole thing, you know. Let's try and get the whole thing. And let me just, because why not, I'm gonna run the PDB parser, which should be here. So here you go. This is a PDB parser, and I would like to go directly to here. And well, here was a pointer. We have that. Let me see the call stack. Call stack. Oh my god. It was even on initialization. There's not even zero. Yeah, it was in 3 runtime. It's like, man, I couldn't even initialize myself. And it's like, oh man, I'm sorry. It's not a problem. You are trying to edit with only files. You want to mark this? What? Jesus Christ, what's all this? No, man, I don't want to get to be inside myself here. Oh, okay. I mean, does that mean that I need to compile and resolve the modules? I mean, we can do this, I guess. pmanager directory. Well, without this, I guess. Alright, I compile. Can I start debugging this? F10. Okay, now it worked. It was getting crazy, I guess. Let me go into the place that we set up. There you go. And you know, we have a create substream, we have a module substream here. I would like to say, hey, module substream, dude, it's gonna have, you know, basically the basic stuff, you know, like it has a stream, which is DBI substream. It has a base, which is, it's gonna be that, and the size. What's all this? Substream index mod info size. Where is that defined? I don't know why do we have this in them. Do we have it unused anywhere? Not at all. I don't know. I mean, this is kind of interesting. What were we thinking here? It was a mod info size. I mean, it has basically all the sizes, but probably do you mean like since they are custom, it's not gonna be useful because we have to get it dynamically. So yeah, I guess I have to resolve that. And I want to go to problem here, which basically is gonna be something like we know the size because of the DBI stream, and it was the DBI header. Where is the DBI header? This is PDB DB stream header. Where is it? DBI stream header. This is the one that has that data, and it has to be substring index mod info size. I don't know if it's called mod info size. Yeah, mod info size. There you go. So in that way we got the size, and now we can parse it directly. Yeah, so now it should work. Alright, I'm gonna run this. There you go, and I want to see what happened. There you go, the size is correct, everything else is just the same, which is nice. And fSubstring basically is going to do the substring pointer back to 0, and there you go. So now we have some kind of way to parse the data, you know, and it's not like kind of a special thing, but it's just something that we can do. So now the thing that we can do is to create basically the whole stream set, you know. So I'm gonna do something like this. I'm gonna just say n32t index, and I want to say module index equals 0, module index is less than, and here is the tricky thing because we don't know how many they are, we just know the size of them. So the size of, I don't know if they have the count, that would be nice. Yeah, we don't have that. The body is an array variable records, we have a section contribution, and we have a module info, we have the flags, we are gonna get that, and that's it, section contribution. There you go. So yeah, we're gonna get them. So probably we want something like u32t byte index, I would say, and probably are gonna do something more of this kind of trick. But index is less than the module substring dot size, and we got the size, we got by index, and I'm gonna do something here special. We have the index to the place, if I believe. The number of bytes of data from the stream identified by nodes that represent Kobe symbol records. The number of bytes of data from the stream identified by module same stream that represents blah blah blah. Okay. I don't know if we have already this been defined. Let me see. It seems like no. We have the manager. Here's the pragma. This is, yeah, here it is, module info. And we have a module name and a virtual file name and the contribution. Okay, yeah, here it is. I put here a note. Module substream data. Here you go. Alright. So the thing I would like to do here is to first of all, we're gonna get some array of them, so I would like to have some kind of PDB module info. It's module, there you go, mod info, and you know, mod info is gonna be pointing to the mod substream base, and probably this can be here. And we can say if mod info, we're gonna start by parsing the first one, so it can be like how can we do this? We know that the first byte, and we can say assert mod info unused, and it's called unused one. Unused 0, I guess I'm gonna call it unused 0. It's gonna be 0, you know, or it can be like this, so that we know that we can get into there, you know. So I guess I need an offset here, so probably how much is it? I need the size of it minus the 64, so probably I want to say let me compile this. PDB module info, I just wanna get the size of that. I mean, we can count it, I guess, but I was just like, let's try here, I guess. I'm gonna go directly and run this, and what I'm gonna get something like size of EPDB module info 80 bytes. So we can get 80 minus 16 is 64. So we can define here something like, I don't know, where can we define it? It can be here, I guess, since it's just gonna be used for this. Or yeah, I can make it define here. Upon define module static module info size. There we go. And we can say we can assert that, and we can say, hey, I want you, and I'm gonna say well, in fact, I mean, we could do something like this. Mod info, and the last element of the module info, it's, I believe, oh, here we already counted. Okay, oh my god. PDB path name index, this is good. I want the address of them, and this is, let's say we're gonna parse the letter strings, you know. Or we don't even need to do that, isn't it? We can go directly to it and say, hey, this is the module name. The only thing, I mean, this is the one that's correct, this one. This is not going to be correct at all, because the data itself there, I mean, it's going to think it's a pointer, but it's not a pointer. We're pointing to that data. You know, yeah, they are wrong by themselves. So we probably want to do how can I do this? These are so we're gonna say copy modules copy name for PDB, copy string, I guess, copy string for PDB, and I want to say the pointer to it is gonna be I want to say I want the address of this, because the address is what matters to me. So yeah, it doesn't make too much sense to have this data here. So we can probably do without it, I guess. And we just kind of, since we don't know the size and nothing tells us the size per se. Oh, is this one, isn't it? Same bad size. Let me see. Put the charger. Oh my god. Oh my god. Excuse me a second. Alright. Alright. Now we have some power. And we can continue. So yeah, I was like thinking, well, how can we get the size of this, you know? The characteristics field, yeah, it's something that's in the image section header. The section contribution, there are some properties inside the section. Oh no, this is the number of bytes in data from the symbol byte size. Which I guess it's, yeah, I mean that's important, but I guess I can do with, I mean we can do some kind of a this, you know? Some kind of a this. I mean, I can put it like commented, but since they're not gonna be correct, I'm gonna say that I wanna go I can even say something like this because it's useful. I'm gonna say a module the base string data string letter first string letter first string letter, and we're assuming here that they are all ANSI strings, but it can be that they they are not ANSI strings and we can have a problem there. So that's why I wanna, it doesn't matter too much because I mean we just care about the address itself, so I think it's okay. So I want to say something like this first string letter And we define here a module to be some kind of way to gather all that data. So we can probably use this one to get it. Yeah, something like this. Okay, we can do this. This can be called source, and this can be called test. We can do something like this. Source, I use 0 source, test, and then I can say something like this. And the only problem that we're gonna have, oh no, yeah, they are 0 string. Okay, so we can say something like source test, and probably we can test equal push struct. We have a manager. I don't know if the manager has an arena or not. Let me see. Here's the manager. It has a temporary arena. Here we go. Perfect. And the size of a PDB module. And I can say test info. It's gonna be the source. And I think I like more this way. And this way. And probably the thing we want to need here is some way of it. Probably we want in32T module name, object file name size, you can have string length, test, module name size, gonna be the P manager. I mean, and probably we don't need to copy the strings here. Probably we wanna do. I mean, in certain part of the thing, if it's not here, it will be when we construct the thing. But since, I mean, we can even call this from the create tracer symbols. That's probably, I mean, is the thing that we want. We're gonna need to do right there. So why don't we I mean, we can say something like this: string length, P manager. I mean, I'm gonna continue it this way. If we see that we can change it, well, we can change it. P manager size. This is gonna be the source, and it's gonna be the first string length, string letter. I want the address. I remember what the string length passes. It was a car, so we can say, hey, please, EagleFly PDB parser. I want you to be a car. And I want the module name size and the object file name size. It's gonna be basically something like this. I remember if the string length counts the 0. It well, yes, it does it in a certain way, I guess. Because if we say, I don't know, something like A0, we say 1, and we say, hey, put me onto that, it will move until before the, yeah, it will be moved before. So we probably want to do we got that. I don't know if we have a copy string. Do we have a copy string? No, we don't, but we can do it. I want to say that I want to push struct, push array, sorry, or push a string, why not, of you know, some kind of car, and I wanna push it to the arena. That is the P manager temp arena, and I want to pass it on directly from there. What's this? No, I mean P manager temp arena core, how many, test, module name size, and basically do the same for the other size. There you go. And I want to say that we have a module name, and we have a basically the other counterpart, such an object file name, and we can say that we need so I want to say something like this. We can do something like that, and once we copy that data, I want to implement this. We don't have a push string, so we can define it. It's in EagleFly platform. I mean, we call it basically the same, so we can say push. I probably want to do this here. So it could be something like that. There you go. And we should take this down. . Now I'd like to see what happens now. We copy up the strings and there you go. So now that we do that, I mean, we're already like kind of building up data that we like kind of we're gonna get from the PDB itself, you know. Where we got the names for the modules, and we can then I don't know if it was I believe there was some mem copy here. I mean, right now, I mean, copy strings fine, but if we want to do something fancier, there's a mem copy. Intrinsic. We can do this. They just make it harder to be unsafe? Jesus. See, runtime functions doesn't guarantee safety. They just make hard. Man. What does that mean? I mean, what's that mean? It's like, oh, it's hard to be unsafe, but it's not safety. Ho ho. I don't care. We're gonna use that. Alright. Alright. But I mean, I thought it wasn't intrinsic, isn't it? I mean, it should be intrin.h or something. I mean, it's because they have it on the string.h or something. Yeah. They do have it on the string.h. No, I don't care. Okay, so we now have some module file name, source file name, and this kind of crazy stuff going here. And you know, it can be this is nice. We know that we can say something like, I don't know, and basically, I mean, all these fellas can go out. They're super important them to be here, although these are I mean, I can define him here, and of the file name, and I can do something like that. The only thing that I care about now is to create a stream that we can get the data from it, which basically is inside. I need the P manager, the P manager directory, and the module info. So okay, and this is not the thing. I want the mod substream, and I want the how is it called module sim stream. There you go. That will create me the stream, and I can get a pointer to it, which is in the test. Well, it's gonna be in the directory itself, isn't it? I don't know how we'll be doing that with the directory. Yeah. So max string count, I don't know how much was it. 128. And create stream would be first block base plus index. We're gonna get the offset, and the size is gonna be the same. PDB stream push struct block count init stream block attilled stream block, and the first block base directory streams. All this stuff, it's nice. The only thing I was looking for is the directory streams. Yeah, it's using the index itself. So if the index it's bananas, it's just gonna do it bananas. So probably we don't want that. Probably we want something like more like this. Streams, stream count, out directory, string count plus plus result, and I think that's better. So we compile, and then we have what? It's a pointer, man. It's a pointer. Are you serious? You think it's not a pointer? If I do this, you're not gonna complain with me? Oh my god. So what do you think it was? Do you think it was not a pointer? I mean, if I do this, what happens? He doesn't let me. If I do this, he thinks it's not a pointer. That's super interesting. What should I be? Would that mean that I need to do some kind of fancy stuff here? No, this is not. He thinks it's a cast. So yeah, I mean probably this. And what if we do this? Does that work? Or do you think this is a problem? No, because smaller knife size is in32T. It's super crazy. I never see like this. We cannot define pointers. Do we need to do this? Are you serious? Is that it? Is that possible? Okay. I never thought that before. That's new to me. But if it's correct, well, it's correct. Alright, so yeah, it's not yeah, I know it's not that, but you know what I mean. I want to PDB. Oh yeah, and this has to pass the stream, and there you go. What? Oh, I need the header. Okay, so I need the header. No, hold me a second. No, this is in. Where is it? It's in the source. I'm sorry, this is in the source. Where is it? Yeah. There you go. We got the source, and we create a stream. The stream doesn't return anything. We're just gonna put it into the manager itself, so we can use them later. And yeah, I think that's nice. What else can we get from the module substream? Oh, and something, yeah, we haven't finished yet. We have to move divide index plus equal to I mean, I can say more simple, I guess. First, well, I have to move it, so now the source has to be moved to the source itself, but looking at it as a core, plus byte index and probably well, probably we got something like byte count. module mod by count is gonna be size of PDB module info plus module name plus EagleFly name size. This is the quantity to be moved, and by index plus equal mod by count. Do something like that, and the source has to be moved by source plus mod by count. There you go. And oh, also, yeah, this is not correct, I guess. It should, I know, it could be something more like this, you know. So we count in to no terminals, and this I'm gonna put to do here because we don't know. Check if both strings are not terminated. They should, but you know. And this has to be cast back to alright. So now we do that, we should assume that we get, oh, and there's missing something here, and is that we have a module, and it has a name, and it has another module to the next. We have so we should have a cache to it, you know. So it should be prev module if prev module and we should have a I don't know, something here like we have a substring pointer and probably one oh yeah, we have a PDB module. It's kind of funny because we already like define the things that we want and we are like kind of rediscovering them. So yeah, we have it here, we have a first module. So basically we want to say if first module pmanager first module I mean it can be something like pmanager I mean we can do this. Well, no, I think I like there you go. You compile. And I don't know if we want to get like, I mean we could, because we can do bananas here, you know. I mean since we're not like kind of like parsing the module stream substring and we're creating strings from here. I mean we can even try to do here the stream extraction, which could be, but first let me just finish to the error thing so we can test it. So we have a PDB module and this is test. We don't have a test anywhere. We don't have a test. It's basically 0. This is a module. Alright, so let's test it since it's something that we like to do. Boom. PDB stream is no. Oh, and this uses the stream index, isn't it? Yeah, it's because we use some kind of crazy stuff. Yeah, so well, probably we're gonna keep it that way, I guess. Where is it? Create stream. and I want to say instead of this we have something different, so I want to say this. And if you think about it, well, now I think about it, we have that enum somewhere. We define it. It should be on the streams themselves. I don't see it anywhere. Oh, is this serious? No. Where is it? Stream index PDB. Here you go. Well, I'm gonna keep it that way, I guess. If we see there's a problem, well, we can do something with that. Alright, I'll start, and there you go. I will create a substream, I will end it, I will continue here. We got the source, move by cam, by index, blah blah blah. Oh, and we have a problem here. A little minuscule problem that we didn't take out. And it's that we don't need this anymore. So yep, I think that should do it. Yeah, so we can see the source, and the source is going to be unused. We have a section contribution, and it does have the padding with something, the section 1. The first string letter is C. Yeah. And we have we can even take a look here. Yeah, I want the address of this. There you go, and there you go. We can see that is C EagleFly test build textbook target that object obj, which is our obj. So yeah, this is the one that the compiler got out, and it's stored inside this PDB. So we got that, and we can continue. We got a value, first string letter, PDB file, path name, index. I don't remember what was that. So it's 0. There's another in use there. what about symbol size? It's 268, and this. So we sum this, it will be the total size for the string that we're looking for. Okay, it's the 13, so it's not super crazy, you know. It's just a little bit farther, you know, the 13. We have the flags. There's nothing in the flags. I don't know what the flags should be for. Okay, so it has that data. We have characteristics, we have the size, of the section itself, section 1, so it's one of the first sections of the image file. We have the padding, it's -1. The characteristics, that's that, which is lives on this place. Let me see. It was this one, isn't it? No, it was the Emacs section header. Is not this one. So can it have just one? Or it can be many of them? I believe it can have many of them, isn't it? Let me see if I can look it in hex. 6552222. So yeah, it has many of them. It has at least image scene link info. Oh no, I'm sorry, no. It has image section count code. Okay, so this section has executable code. Cool. We know that because it's here. We have executable code. We have 200, so it's something like this. Reserved. It's reserved, but we don't know what's them. We have 50 and 6 zeros, which is nothing, I guess, but it's 1, I guess. 1 2 3 4 1 2 3 4. What? I cannot see, man. I cannot see you, man. 1 2 3 4 5. 1 2 3 4 5. Image. 1 2 3 4 5 6 2. And it has a 5, so it's not that. So it has the combination of these. It has the section cannot be cached, and it has the Emacs section link lock of the flow. So the image file has some relocations. Well, no, sorry, this section. Oh, okay, I got it. So the number of relocations is the counter of how many relocations have been placed in that section. So it counts so that if it overflows, you know, if it's bigger than 16-bit data size, it's gonna put this flag on and tell you, hey, there's more relocations that I can store in here. So you can go and look at the other relocations in the virtual address space for the first relocation. It's like, hey, something happened. You should take into consideration that. So I don't know why this does have any relocations at all. I mean, I don't know why relocations are for, but we should look at we should take a look at that later. Yeah, so we have a bunch of that. We have one, and we have it cannot be cached. Okay, that means reasonable. And it has another one, which I don't think it's here. Yeah, because this is huge. If you think about it, it's gonna be 8. 1, 2, 3, 4. I don't know. Oh no. 1, 2, 3, 4, 5, 6. Oh, I'm sorry. It doesn't have that. It just have 5 zeros behind. So it should be 1, 2, 3, 4, 5. Align data on a 16-byte. This is valid only for object files. Okay. Okay. Yeah. Okay. So it's a 16-byte boundary that aligns the data of everything, or just that section. Yeah, but that's that. It's the 5 in there, and the 6 in the other part. It should be a 4 and a 2, isn't it? So this section can be read, and this section can be executed as code. Okay, so I can read it. I cannot write it too because it's code. It's a section of code, which is interesting. And, you know, I mean, I have now. This has blown into my mind. Like, I mean, if I can write to the section of the code, you know, the code section, how could we write that CC, you know, instruction tree, for making a breakpoint? You know, that probably makes no sense at all. Probably makes no sense at all. How can that be possible? That means, is there a way to really write code? There's a way. So yeah, I mean, we have an inquiry there, but yeah, I mean, we're not like looking at that right now. So yeah, we have a module index. It's 0. It's a okay, so it's 0. We have a section. That's the 1. The padding. Data CRC. I don't know what's that. And relocations. Okay. So now let's take a look and see if we can get the other data. I'm gonna put it here. It has 43 and 43. Object file name is and module name, they are the same. That makes sense. And I'm gonna store that in here. And when I copy the string, okay, we have a bug in there, which it's, I mean, it's even like kind of, I can see the problem without looking at it because it's kind of hilarious. And yeah, there's a missing plus plus in there. Alright, my bad. We can set a breakpoint here so we don't go too long far away from here. I can stop this thing from being the bug and reinitialize the begin count. I want to toggle this, I want to run this, I want to continue here. There you go, we copy the string. I want to see now what's going on. Whoa, it didn't copy it at all, so what's the matter now? Didn't we compile? Okay, once again. And I want to see the size. Oh. And oh no. So I should be able now to see something. Of course, well, I mean, it probably works, but I think I should do something like this. So we can say you know what I mean? Okay, now it worked. And hey, look at this. There's no pointer. There's no terminator string here. So that's a tricky one. Because you think 1, 2, 3, 4, 5, 6. Yes, they're 43. Okay. Does that mean because they are pushed along? Yeah, it makes the whole sense. Yeah, because we're pushing it like just one beside the other without the no terminator. I mean, it's like even like, I mean, we're doing bananas here. I mean, I mean, it can be useful, of course, but it's gonna be problematic when we use it. So we should not we should not do it that way. Because if you think about it, we have now, yeah, I mean, this is the object file name. It's gonna be the same. It's gonna be 43, and there you go. You don't have anything here. But here we can take a look because there's no pointer, and that's funny. So yeah, we have to do that. Let me just check this also so we can say that we got first module. There's no, we can't do that. We create a string. Now, well, I step over, but I didn't see that, so probably I kind of see here. It's on the 12th, no, the 13th, sorry. It's gonna have size is that, okay. This is the size. This is the block count. And let me see if that's correct. We have source. And source is this. And and out directory. Well, it doesn't necessarily say that. If we sum up, so yeah, I mean, we have the number of bytes of data that the stream identified by module send stream. It's called view symbol records, and some other byte size for code view line information. But they don't say how much big this stream is gonna be. We know it because of this. So this is correct basically. This out directory. Its size is bigger than just that, so it probably has more data than just that. But yeah, I mean, it has probably sense that's just certain kind of data, you know. We have a first block base, it's there, and the sentinel is something, next is something. And index is this block, and the base is blah, and everything is okay. Okay, that makes sense. We're gonna continue moving around. Now here's the thing. The source now, let me look at it. The source now, it seems that it has some data. I'd like to see it in memory. So yeah, this is incorrect. This is incorrect because of the same reason. So we should take that into the same consideration. And I want to say something like this. Well, pretty much. So no, well, I didn't see it, but yeah, because if he had it, there is the module. So yeah, so this is more like like this. And we should copy it that way, and in that way we don't need to do this, and I think it's better. And we can put it on the string length itself, but sometimes we don't want that itself, you know, so I think that's good. So this should be 44, there you go. And now we should be properly, yeah, there you go, it's perfect. And this is perfect. Okay, continuing this, we have a prep module. We're gonna create a stream. Get the size, that's that thing that we should, that's that. We do everything, and we say, hey, there's just one, and then it's just the index. And then we say, hey, the mode by count, it's gonna move it, I wanna see. Okay, we have another one there, and there you go. Let me see the used. The unused, I want to say memory, and it's the same, but now it has some data in there. Now I want to see the source itself. Does that make sense? Let me see this first string letter. This doesn't make sense. Let me see this in here. I want to see the address, and yeah, it's one more because it's in the, yeah, it's missing the root, so it's 1 byte outside. So that means that rather we are like I mean, not all of them has the size. Oh yeah, no, I'm sorry. I'm totally stupid. I have to, yeah, I remember what we got, and the reason that doesn't work is because we did something that probably now it was a feature that is not helping us at all. So we should take it out. It's inside here, and it's this thing called first and letter, because you know that's the problem. So we should, I mean, it's better if we just do it manually, you know. If we say that we want the PDB file name index, and in fact we can say something like you know, say the source plus size of source, you know, or more PDB module info. And there's a place where we should be. The source, there you go, yeah, the address, and for there we can get everything else. Alright, that's pretty much better. Let's try it one more time. We're gonna get it. We can see okay, it doesn't look like. Let me see the source itself. That's good. And I mean, the bundle name is totally busted. And let's see if we can see the data. Oh my god, this is not even the place. There's nothing here. Oh my goodness. What happened here? Okay, yeah, it's not this, so well, yeah, because we have the base, but did we paste? Oh, we don't want the address. Yeah, we don't want we just want the source. Yeah, I mean, we want something like this. Yeah, we don't want the address, of course. The address is not pointing to the volume, but we want we can say this. Yeah. Yeah. What about now? There you go. Yeah. This is the thing we're looking for. There you go, it worked. We have a module name, and this module name is F binaries intermediate VC tools live CMT native project ovgd exe main dot object, which is something that the compiler basically adjuncted it and copied to the project itself. So it has the module, it's gonna use exe main object and others, you know, so I have many of them. And I don't know where, I mean, if I put this into to here. But I don't have any F, so it should be some hidden directory. Yeah. Okay, so I'm gonna try to load that, if it happens to that or nothing, but because it's done aesthetically, I would guess. Oh, here you go. Here you go. This should not be possible because we know that string count is 679. Well, yeah, it could be, it could be. I don't know how many, it was in the super block. Let me see. P manager. But we just have 907 blocks, and this is going to the 12,800. Oh my god. What's all this? And this doesn't have even a name. What's going on here? What's going on here? Okay. Did we didn't get it right? Or what? Let me go back because I didn't see it correctly. So now the source So then seems wrap. I can wrap. So yeah, here's the problem. The place we're getting on, it's being compounded not correctly. And we have wonder. Oh my god. What happened here? Why does the object file name has this if binaries intermediate VC2s? Just one? That's kind of crazy. It should be in there. So probably we don't even get to the last part. Does that mean that the source is wrong? I want to see the source. The source is BB, so this is it. And yeah, I can look at this 8-byte integers, and we know that there are 8 of it, you know, in BB. I can put it a source. And we should see 1 2 1 2 3 4, and then we should get it. But it's that dot there, isn't it? We have FB, yeah, we have in FB, but in FB there's nothing. I mean, there's a null. So are we not padding it correctly? Because if that makes sense, this just got to one of it instead of getting both of them. We have here also other one, and this is another one. So does that mean that let me run it back. And if I see the memory, let me see the source. There you go. And we have EagleFly tests, and we have C. We have it on X0, that's good. And this is on AC, which is something like here, it's good. And then we go continue. I want to see the source back again, and we see the source, and now it's in D8. It should be here. Oh my god, what happened here? What happened here? Let me copy back. Oh, there you go. So this is the 8. The 8, it's a null, and it's good. So if we run it, we get the modules, and the modules should look right. F binaries, intermediate, and C program files, x86, blah 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 blah. And this model name size 686, and this is 0. Okay, this is a 77. We're gonna push it, and the mobile count is 227, which should get us to the place where we want. It should be 2d8, isn't it? Or no, somewhere else. Man, this is like the code, man. It's super hard to read this thing. It doesn't have any highlighting in any stuff. Thank you, Mr. Visual Studio. Let's continue. Now this is okay to 27. I want to see where the source end up right here. Now the source itself is gonna be PDB. Which is that. It seems right to me because it has an order. And we should get until here, you know, should be here where the F binary thing happens. It's a 4, I don't know how many they are, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we have a test, push struct this, blah blah blah. And module name is nothing. So yeah, something's busted, but I can't see which of them. Something happens between this and this that it's not correctly moving the pointer, because this is in BB and this is 64. So how many they are here? I want to see it on date. I want to copy the PB. And then I see this. Oh, it's because it's like, why do I see an after? But yeah, it's because it's little endian. So it goes from here to here, and it goes from here to here. So it goes from here, and you see this is a 0. This is a 0, which is this little dot here, which you don't know why is there a 0 here. Are we missing something? We have a 0 here, and that's kind of, I mean, I don't know if the PDB is busted or not, but there shouldn't be 0 here, unless we are not counting on it, you know. And probably we are not, because this is 0 0. Yeah, this is the 0 0 that we didn't count. So yeah, I mean, maybe you shouldn't start on that, because this should have another 0 0 there. So that probably tells me that, yeah, I mean, if you look into BB, let me go back to byte. I copy this. No, yeah, it's correct, because we have a 0 0 on BB before BB, sorry. Man, this is 1, 2, 3, 4, 5, 6, 7, 8. Man, are you serious? man, this is tricking me out. It's putting this 00 back in here. Why? Yeah, because this is 62. This is... I should be looking at 62 on the 8. Well, of course it's gonna change because... yeah... I mean, I'm not gonna see the 62 at all, I guess. Oh, yeah, here it is. This is 0062. Okay. It's like, oh, where's the 00? Here's the 00. Oh man, little endiness, big endiness. So yeah, that's correct. It is correctly placed, but if got... I'm sorry. This has a 00 extra there, so we don't know why. Does this thing tell us something about that? This looks right to me. There's nothing weird on this, you know. This is totally interesting to me. We are not getting it. I mean, it would be trivial if we just do it the same way. And there are a bunch of them, you know? there are like a big bunch of modules that we have to take a look into, and pretty much, I mean, we don't care too much about them, but yeah, here's the section contribution section, substream, which is some extra things, and this is some extra things. We have to find out why should it be not the case. I mean, because the others were right, eh? I mean, the others got a good idea of what was going on, you know. It was not something super crazy. Of course. Okay. One more time. This is the norm. And this should have a null also. There you go. And these are the two bots that we're not, the no bats. So that we made that right. Push it, we copy, we do blah, we move it, and then the source, it should be the same, you know. We have the f binaries blah blah blah, which is the next one. There you go. And it's that's right. I mean, that's right, and that's crazy, because if that's right, why isn't it right for the others? And then this has a null here, and here's where the other one starts. That's the C programs. This is C program 566. Got awesome. And then it has a null terminator, and then everything should start back again in the same way. in the same way. We copy the string. We have a model name there. Let me see the data. It looks fine. And the object file name. This is an important one because yeah, it has a leaf and it's fine. So that looks really fine. What's going on here? What about move by count? 227. So if we say source, if we say source multiplied by count and the wedge, if we're moving along, we get to the BB, okay. Which is correct. Until that part it's correct. But the problem is the size of the, we're getting a problem with the size of the module info itself, because it seems like now it's something that is not totally fixed, but it changes. So if we go to BB and we copy that, oh my god, and this is BB, and here's where we start, and that's perfect. That's what we want. It's gonna have some unused data, which is 4 bytes. 1, 2, 3, 4. 1 bytes. I don't know why they changed the. It just. Visual Studio. I just changed the layout, and it's gonna make all these junky stuff. The place where we doing it is now gone. That's nothing good. You should keep this all the time. The place where you are looking at, and moving an offset from there. So yeah, we have BB. That's perfect. 1, 2, 3, 4, and look. This is bad. This is bad because this should be 4, and then the others. If you see these. If we see the source, can you see where's the source? This is source. This has a different section contribution. I don't know if that's the problem. Yeah, because I can see in the pre-manager we have the first module, and it has, but it's gonna have the section contribution is 41, and the next one, section contribution, it's also for 1. So I think it should be 1, I see. So that, it doesn't padding, blah blah blah, 48 offset. So yeah, we're getting it wrong on the last one. Where is it? Yeah, because if we say 1 2 3 4 bytes, 1 2 3 4 bytes, well, it didn't make sense either, isn't it? Because these are the 1 2 1 2 3 4 bytes, and then it's 0 1 2 3 4 bytes, and this is the layout that we should look, this one, and this is the one that we are not looking at. I need to see these bytes as well, and we have them, you know, we have them right here, 1 2 3 4 bytes, and the same data it goes as well here. The problem is that we are not getting onto there because it's missing one byte, another byte, which I don't know where does it come from, because this has a 30, which is 0x30. Well, I want to see the car. Yeah, it's 0. That's good. Could it be possible that it has 2 bytes? It's totally wrong. Because you see here, for example, this leaf, it has 1 byte, and then it has 1 2 3 4, and then it has 1 2, and then it has the 0 1 0 0 FF, which is the same. And this is the thing that we should be looking for, but it's getting bad here. I mean, this gap here is getting bigger every time. If we see here, we see the same pattern. It sees this blah blah blah, and we have 1 2 3 4 5 6 7. This is telling me that something's busted. The interesting thing is that we have some kind of good reference here, because these bytes are telling me that, yeah, this should be, I mean, we are assuming now, of course, I mean, we are not totally sure, but there should be a reason why not to. I mean, the problem should be that we have a problem with the string count then, because there's probably more strings here, you know. Like, I mean, probably the count comes until here, so there are 4 bytes, 4 new bytes, which doesn't make sense anymore. we have here another one, and yeah, this doesn't have any more of that. It has a 0, and it has 6 bytes, which is totally different. The pattern should be behind. Probably there's something we are not looking at. It's kind of tricky. It doesn't say anything here. We should take a look onto this thing and take a look. I mean, what we could do for now, and I mean, probably this is a little bit janky, since we know that, well, we're not for sure tall, isn't it? And nothing tells us like what's the size of it. We can like okay, so let's go to So this has some pages. This is a sec map, symbol records. Oh, here it is. Is the section map. Let me put this in somewhere else. And this is the should be this one. Oh my god. Section map size. We have some sec map. And we have a sec map. We have what is it? Buffer section. What is this? Symbol records, global modules, module something and module something. Module. And frame data. PD Bugger frame data. Global converted. Don't allow adding tab servers. Okay, PTPI, types mismatch. Okay. This is the head to the TS, which is the I don't know. Open debugger, verify, mode last, ferment, instrumented, not PDB use, type mismatch, warning, query PDB, PDB1, fix buffer, there's a module information thing going on. Yeah, convert module information from size T to size C. Okay. All the module informations are already in size C format. Just that the strings are in MBCS. Must convert them to UTF-8. Ooh. Does that mean that they change it to UTF-8? Does that mean append? What's SC format? SC format. No, I don't want a compression. I don't want compression. MBCS format. Does that mean that we have something quirky going on there with UTF-8? I don't think so. I mean, if it's UTF-8, it would be the same because they are 8 bytes. If it was UTF-16, that would be the matter. But I don't think that's a problem. Copy on string data. Let me see. We have a buffer. We have a pen to the star and the size and the blah and the false. Reset the star. Mientras que while it is and then it's like till the end. Align. Expect align native. All right. And here's copying all downstream data. Probably this is an answer to us. Oh, here you go. Look at this. Does that mean that, I mean, for any stupid reason, the PDB itself has some trailing nulls. I mean, just look at the S after the null. Okay, so here's something, man. So there's a buffer 24A, and there's size C, CP, the buffer, CP buffer, no CP buffer, no CP buffer, man, no CP buffer. There you go. Oh yeah, this there is just MBCS to UTF-8 of the SC buffer, of the length of the mod information on the, I don't know what's this, but some pointer somewhere, and the size of the buffer and the length. Copy translated strings. Do you see here is +1, just as we have it here, +1 +1. And yeah, yeah, basically, I mean, that's perfect. I mean, we're doing it correct. The only problem is this: it has trailing nose. So we can expect trailing nose into there. Oh my god, that's something to consider, isn't it? Okay. Probably. I'm assuming that. I mean, if this is like the loader itself, it should skip it. But we can't assume nothing from SDN. If they have trailing nodes, they will have trailing nodes. You know, and we should work against that. That's super interesting. So I mean, I don't know why does. I mean, all of this is skipping. Append format, append size of buffer, static cast of blah to the CP buffer. Oh my god. Okay. I think so, yeah. I mean, they are like skipping. How many? I don't know. I don't know. I mean, I don't know how many. Let me see. Let's make sense of it, I mean, we know we are in source. Let me go to source. I can copy. There you go. So we are in source. That's here. And we should skip trailing nodes basically onto here. I'm assuming. The only problem, of course, is that we cannot assume anything. I mean, the best idea that I have to do this, and I mean, probably it's not the best way, but we're gonna start with something. I know that we know something for sure. I mean, I don't understand this buffer appends and buffer stuff, but I mean, we are for certain sure that they are doing some fancy stuff to remove dead nodes, just as the way that we were doing it. And what's this? Yeah, because this is the convert mod information from SD to SC. We never use new header before version 5. Okay, look at this. We have a section map, account for the section map, for the debug header, for the section map, debug header, by the file info, and the TS map, and the DBI header, and the modification. Yeah, look at this. This is the way that yeah, this is the way how LLVM phrased the structured way, or the structured thing, how he was doing it. He just saw like, hey, I mean, and it's kind of intuitive somehow, you know. I mean, you know that. I mean, the whole can of it should be the stream, you know, the header plus the modification section, the module section. Then there's something here, I don't remember. It was the section contribution is this one, section contribution count bytes, and this is the section map count bytes, you know. This is the source info or file info count bytes, and type server size.
It's currently partly cloudy and 22 degrees in Saarbrücken.
And then there's the debug header size. Yeah, I mean, look at this. They got it from here. It's pretty much the same. And they use zip substream info. It's just perfect. And yeah, they have dynamic asserts and compilation asserts, if I believe that's what they meant by that. And then blah 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 blah. Okay, that makes sense. Can incremental link a BC4 format PDB. We have introduced new scheme to track a reference counts and promote global systems. Return a format error here so that we force a full link and rewrite of all of the module streams. On the 95, on the 90, man. Oh my god. Okay. This is from the, is that coming from the 95? Just can incremental link a BC4 format PDB. Alright. Okay, are we rewriting this as a BC4.1 DBI? Set last server, blah blah blah. Reading the GP modification status. Okay, perfect. This is the reading. Look at this. This is the essence. This is what we are doing right now. DBI header, count bytes of the global modifications. Module info. Okay, so it has a version 5 module information into temp table of a buffer to the global pointer to modification information, module information, and there's the, okay, so they are kind of trying to do with two versions. They are dealing with two versions here. We have a version 5 for the PDB thing, and we have serve no zeros, set OOME error, and then we have a read stream from the PB version 5. on to the count of the module information. Okay, it's gonna load everything. Yeah, it's loading from, it's basically loading this thing from here, so it knows, hey, I'm gonna load everything. Pass through version 5 module information table and copy convert into version 6 module information table. Okay. We have a PB counts, PVM, PV. Okay, this is version 5, and this is the loop that we have basically, and this validates size of the SC module and the object file, size module and size object file. Hold on. This is the offset, and this is the GP modification size. I want to copy this. I mean, it's super hard to read right here, so I want to copy all this stuff. Oh man, this is huge. This is bananas, man. Look at this. Alright, let's copy it. Come on. Come on. I should probably use Control A, but doesn't matter. I want to copy that, and I'm gonna create a new file here that's gonna be dbi msdn dbi.cpp. Look at this. Okay. Alright, so right here we can, let's go to the place where we are looking for the, it's not here, how's it called? I don't remember. It's this one, isn't it? Infinite. Here you go. Here, infinite. It has, okay, I wanna see the p mod d, control 5 p mod d. It doesn't has any p mod d. Where is the p mod d? Here's the p mod d. I don't think we have a module structure definition for this, isn't it? They use it, but they don't. It's not here, isn't it? No. But it's in the Langapi thing. So yeah, we can take a look at that. I can use msdn pdb.h find modi, and that's all. So yeah, it's not here. It should be here. Modi size object file modi p modi. Look at this. This is p modi. Where's p modi? P modi. Oh, here's p modi. It's a 6.0 p modi version, and we're like allocating something here and align native. No, it's not here defined. We have to look it somewhere else. We have the count bytes for the GP model information and the count bytes for the memory max. Reserve no zeros, DBI header. Okay, here you go. Oh, here you go. Look at this. They are changing here all the models from MBCS to UT effect. So yeah, basically that's the problem. We are seeing it here. We need to add like this kind of usefulness. You know, we have to convert modi from blah 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 to blah blah blah. And since we don't care too much about them, I was just like repeat G. This is a section contribution, so yeah, it has already passed here, so it should be here. If it's in size format PDB, convert module from STC, blah blah blah, PV buffer modification. So is this like a pointer to block? Yeah, it's not here. It's not here. It's not here. We have a size T. So we should expect some alignment to be native of the pin body star. A pointer to a block. Okay, it's gonna move this, the size of the model information, and the model information. Okay. So yeah, I mean we should do the thing that we're thinking through. So yeah, I mean this is the thing we're gonna do. It's gonna be pretty much simple. What we're gonna do is simply we know how much the size of the DVI that's static is 64 bytes. So we have that pretty much done. You know, we have size of blah 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 is 64, and it's gonna do it for module name. So now we can do its basically, before doing all this stuff, well, I can do it here, I guess. What I'm gonna do, oh, I'm very close, isn't it? Do I compile? I'm gonna do something like this. Yeah, because well, I don't want to do like junkiness, but I don't know MPCS files. How do they are like kind of done? I mean, the thing that I was like thinking on is like I don't know. I'm gonna put a breakpoint there. I'm gonna put on the wedge. I'm gonna put on the source. Where is the source? Here. Onto memory. What? Oh. Dang. Again, I guess. Source. There you go. And we have basically we need a way to offset that trailing zeros, you know, and we have several ways to do it. One way is just to go straight on until we find some sign bit, I guess, and check if we have a 64 by, you know, alignment or something. If we don't, we just move the pointer to get that, you know. So but 64 by alignment to what, you know? 64 by alignment to a non-trailing zero or what? And probably that's the thing, because I mean, but we can assume that the thing that, where is it? It was on the here. Yeah, path name index. I mean, we can assume that this is gonna be 0. You know, in the on the last by, or in the, yeah, on the last by. You know, I mean, we know that it's in most of the time it's 0, but most of the time, but it should not be. This is kind of hard. Because the problems are the strings. The strings are the ones that are having those trailing zeros. So we just have to remove those trailing zeros. I don't know how, sorry. For example, right here they are there's 1, 2, 3, 4 bytes. And there's a unit 16, which is a section. And here's something bananas, like 1, 2, 3, 4, 5 bytes. This is 5 bytes, so this is wrong. So should it be the alignment, natural alignment? Let's see. We can check that. Let me see. We can use the natural alignment. We know that the first one is good because the size is 44, okay, and the size is 44. So if we have 44, let me do this. We have 44 for each one. There's no trailing zeros on 44. And now we can move. And now we do the same for this, and this is 86 and 77. This is 77, and it has 1 byte more, isn't it? Yeah. How is it? So probably it's aligned to a 2 byte binary, so it's always even. For example, this is ours, and this is good aligned. It's respectful. It's 1, 2, 3, 4, but 0, and then it's 1, 2, 3, 4. And then we have the alignment, and then this one, it's the one that's not respectful. It's missing 1 byte, and we have 1, 2, 3, 4, 5, and then the 0, 1. So we're missing 1, and this because of the 77. So we have 77 and 86. And this is 44 plus 44. So this is 88, and this is 163, which is 256, 124 is missing 1 to be 164, but 164 it's we have I don't know, something. this is 85. And this is I mean, we can follow the line that they are doing right here, isn't it? Like, where is it? And the DBI, they use, they first uh, they have the lens, and yeah, I mean, this is the thing. We have to do something like this. The problem is that we have to look for these definitions so we can see what's going on here. We know that a line native, it has to be to the boundary of a native, you know, but I don't know exactly how do they do that. It has a format, probably it's I don't know. It has a pen. I mean, a pen from this context, it looks like it's like adding to this stream, like, hey, this bytes now I'm check, you know, check or something. So yeah, there's a pending on there, you know, and they have this MBCS to UTF-8 that this is the one that I would like try to look somewhere, you know, because basically this is the length, the size of buffer, and the 294A. And this CB buffer, they use it here. So let's try to look there. I don't think they should have it on the MSDN, PDB, MBCS to UTF-8. No, there's no there. So yeah, we have to look at that. We can try to look at this. Let's see if we have it here. Yeah, SCST. Okay, this should be. Here is the place, isn't it? And what's the name of it? MBCS to UTF-8. Oh my god, this is it. Oh, okay, so let's see what they are doing here. They are doing what is called Okay, so the first parameter is account CC or size T. The size T is MBCS. The count bytes from the MBCS. The count bytes from the MBCS. Okay. And I'm gonna, oh my god. Here we go. We have MBCS. The first parameter is this thing, which is the size of MBCS. Okay, so this is a transformation from MBCS to UT effect. Okay, let me see. I mean, probably the MBCS is not the problem, but I'm gonna find DCB align native. DCB align native. Here you go. They have MD align native. DCB align. DCB align native. Okay. Okay, they are doing a mask, but size of NDNT. So we have to look, what is this? It's the only place. It's here also, so you can look at, yeah, here is it. It's an N64. So yeah, here look into the architecture itself, to the IA64, Alpha 64, AMD 64, or ARM 64. Okay. And CB, the one they are using is they're using the Align, but DCB Align native, yeah. Okay, so I think we would do it, we will stop here, and we would do it on the next stream. Now that we have like the idea of what's going on with this, we can do it. And yeah, so yeah, I think we will continue on the next stream. So please, if you have any questions, you can post them on Twitch, Twitter, or YouTube, and I'll be there to answer. For now, I think that will be all, and I will see you all on the next stream.